Number 21. What is the change in the nucleus that results from the following decay scenarios? So what's going to happen when we capture an electron? Woohoo, okay. So what's going to happen when an electron is captured? And what's going to happen with that nucleus? Now, when we're talking about the nucleus, there's only basically two subatomic particles, right? There's protons that are residing in the nucleus, and there's neutrons. So probably we're going to be talking about the change in either, what's going on with the protons. Are they changing? Are we losing them? Are we gaining them? What's going on with the neutrons? The same thing. And what's going to happen with those when we capture an electron? Okay, so an electron is the easier way of saying a beta particle. But electron and beta particles, tomato, right? Tomato. So whether you want to write it in nuclei notation as an E for electron or a B for beta, it doesn't matter. Maybe let's write it as E because I like to use the beta, but we could use E for electron. And just know that electrons, right, they always have a -1 charge. That number always goes on the bottom. And since they have nothing to do with the nucleus, it's a 0 up on the top because the nucleus has no electrons, so that's why it's a 0 up there. Now, we're going to capture that electron. And if you capture something, you ain't letting it go, right? So as far as this balanced equation, right, because this question is probably easiest to answer if we talk about it in terms of a balanced equation. If we are capturing an electron and you're not letting it go, right, you got two sides. You got a reactant and a product side. And anything that's on the product side is always made and it gets let off into the environment. But you're capturing the electron. You don't want to let it go into the environment. So if you see the notation for a capture or electron capture, alpha capture, right, proton capture, I don't care, that particle, or whatever you're capturing, that particle is in the reactants. So now I know that this electron is over here. So let's write it out. We have an electron. And now let's do the colors, right? We got the number on the top, which we said was 0. And we have the number on the bottom, which is the charge of the electron, which is a -1. So now we have to decide what's happening with my protons and neutrons. So I wrote down the nuclei notation for protons and neutrons down below. So I know that, remember, the top numbers across the board, the sides, they have to equal. So the total mass number for the reactants have to equal the total mass number for the products. And the total atomic number for your reactants have to equal the total atomic number for the products. So tops go with tops, bottoms go with bottoms. Now, I see here that electrons have nothing to do with an atomic number. So if I put, let's say, the proton on the left side, that has a 1. So that means that the 1 has to go on the other side, which means that I can't have, a proton and a neutron on the same sides, 1 for 1. But now the question is the proton going to go here or the proton going to go here? Well, let's look at that number down below. Electrons, and maybe I'll write that down. This is the electron. The electron is a negative charge. So you need to basically counteract that. What subatomic particle has a charge or an atomic number? Yeah, the proton, right? The proton has a +1. So if I bring this proton up here and I add these two together, 1 plus a -1 is, overall 0. The neutron is a 0 charge. 1 plus 0 for your mass number is 1. Neutron is a 1. So I know that the proton has to be on the left side, the reactant side, and the neutron got to be on the product side. But now we just got to say our answer in terms of words, right? So what's going on with the nucleus? Seems like you're taking a proton and you're converting it into a neutron. That's what's basically happening when you capture an electron. when something happens and the electron is being withheld, you're withholding the electron, the proton is going to turn into a neutron. So we'll say proton converts. That's a better scientific term, right? Converts. Ooh. Proton converts into a neutron when that electron is captured. And that's basically the final answer. Let's box it off. And ooh, that looks good. I'm liking this. That's the answer. What'd you think? I hope this helped. Thank you for coming here and watching the video. I love helping you guys out. Let me know in the comments. I try to get back to you as much as I can in my spare time. We opened up memberships on the channel if you want to be a member. Not mandatory, obviously, but if you're considering, thank you so much for actually considering. There's 4 different tiers, so maybe one tier, suits your fancy. Go check it out, right? Thank you, and I hope you're having a lovely day out there. Keep studying hard, and I'll talk to you soon. Okay, bye-bye.